velocity. Velocity means how fast something's going. Instantaneous velocity refers to an instant. Average velocity refers to an interval. So instantaneous velocity is how fast the thing is going at a particular moment. Like if you're driving in a car and your speedometer moves up and down, every moment you look at the speedometer, it's telling you how fast you're going at that moment, at that instant. It's telling you your instantaneous velocity. Well, it's telling you the magnitude of your instantaneous velocity for that instant you're looking at it. But average velocity refers to an interval. How far you go in that interval divided by how much time that interval took. We are given data about the instantaneous velocities of this stone at different times. At time 0, the velocity is 0. So that's the moment that the stone is dropped. Just before it starts actually moving. It's not moving yet. Its velocity is 0 meters per second. A second later, at t equals 1 second, it's going 10 meters per second. If we could put a little speedometer on the stone, that's what the reading would tell us at that instant, 10 meters per second. A second later, it's going 20 meters per second. It gets faster and faster throughout that second, and by the end of that second, it's going 30 meters per second. During the next second, it gets faster and faster and faster until by the end of that second, it's going 40 meters per second. And at time equals 5 seconds, it's going 50 meters per second. Those are the instantaneous velocities for the stone. Now, what about the average velocity for each interval? Remember, average velocity means how far it goes during that interval divided by how long that interval takes. We've already calculated that during the first second it traveled 5 meters, and that second had a duration of 1 second long. So its average velocity for that first second was 5 meters per 1 second. 5 meters per second. That's interesting because can you see 5 meters per second is halfway between 0 and 10 meters per second, the initial and the final velocities for that interval. Let's look at the next second long interval. We've already seen that the displacement for that interval was 15 meters. That interval had a time duration delta t also of 1 second. So the average velocity for that interval was 15 meters per second. Again, notice that that's halfway between the initial and final velocities for this interval. 10 meters per second is the initial velocity, and 20 meters per second the final velocity for this interval. 15 is halfway between the two. Pause the movie as you work out the missing values here. During this second, the stone traveled 25 meters. The duration was again a second, so the average velocity 25 meters per second, again halfway between the initial and final velocities for that interval. The next second long interval, the displacement is 35 meters, again in 1 second. The average velocity 35 meters per second, halfway between 30 meters per second and 40 meters per second. During the last interval, the displacement is 45 meters, again in an interval that lasts 1 second duration. The average velocity 45 meters per second, halfway between the initial and the final velocities for that interval. Now you could do this for any interval. The intervals we've been using here are all 1 second in duration. But let's maybe take the entire 5-second interval shown here and let's see what we find. What's the average velocity for the entire duration from 0 to 5 seconds? We know that the entire displacement is final position 125 minus initial position 0. 125 meters. The stone falls 125 meters during this interval. The interval's duration is 5 seconds long. 5 seconds minus 0 seconds equals 5 seconds duration. So the average velocity for the entire 5-second interval is 125 meters traveled in 5 seconds, which is 25 meters per second. That's the average velocity. 0 is the initial velocity, 50 meters per second is the final velocity, and halfway between 0 and 50 is 25 meters per second. Let's take another interval. What about from time 1 second until time 4 seconds? How far does the stone travel? At time 1 second, its position is 5 meters. At t equals 4 seconds, its position is 80 meters. So the change in position, the displacement, delta x, for this interval is 80 minus 5, which is equal to 75 meters. The duration of that interval is 3 seconds. How do we see that? Final time is 4 seconds. Initial time is 1 second. So 4 minus 1 equals 3 seconds. You can see the 3 seconds passing there. So for this interval, the stone travels 75 meters in 3 seconds. 75 divided by 3 equals 25. 25 meters per second is the average velocity for that interval, which is also halfway between the initial velocity, 10 meters per second, and the final velocity, 40 meters per second, for this particular interval. Let's take one other interval as an example. Let's take from t equals 3 seconds to t equals 5 seconds. How far does it travel during that time? Final position, 125 meters. Initial position, 45 meters. So the displacement for that interval, 125 minus 45, is equal to 80 meters. So the stone falls 80 meters during this interval we are speaking about now. How long is the duration of time for this interval? You should just be able to see that it's a 2-second interval, but let's use the formula. Final time minus initial time. 5 seconds minus 3 seconds equals 2 seconds. So the stone travels 80 meters in these 2 seconds. So its average velocity is 80 meters per 2 seconds, which is 40 meters per each second, per 1 second. 40 meters per second. And indeed, 40 meters per second is the halfway value between the initial 30 meters per second and the final 50 meters per second for that interval that we're looking at.